Hey there, SPM Chemistry students. Welcome. Today, we're going to crack a topic that can feel a little tricky, but is packed with real-world importance: isotopes. Let's break it all down so you can absolutely master it for your exam.
But before we dive in, let me give you a pro tip to help you lock in that A+. You've got to do active practice. Seriously, it's key. Head over to MCQ SPM.com or just scan this QR code to practice tons of past year questions right on your phone. It is a total game changer for revision.
Okay, let's get right into it. To really see why mastering isotopes is so important, we're going to start with a typical exam question that I know can look a little intimidating at first.
So, does a question like this make your heart beat just a little bit faster? Don't worry about it. My goal here is to make you feel totally confident when you see this stuff. By the time we're done, you'll know exactly how to solve this, step by step, no problem. Okay, so to handle those calculations and all the application questions, we need to have a rock-solid foundation. So let's start with the big question. What exactly is an isotope? Let's use a really simple analogy. Think about identical twins. They look the same, they pretty much act the same, they share that same core identity. But what if one of them weighs just a little bit more than the other? That's basically the idea behind isotopes. They're just different versions of the very same element.
All right, now this slide right here, this is the official definition. And for your exam, this is pure gold. Examiners are looking for these exact keywords: same element, same number of protons, and, you guessed it, different number of neutrons. You have to memorize this sentence.
So, here's the most crucial point. Because isotopes have the same number of protons, they also have the same number of electrons. And that means their chemical properties, how they react with other things, are identical. The only thing that changes is the number of neutrons, and that affects their mass and other physical stuff. And this is a perfect illustration using carbon. You see, whether we're talking about carbon-12 or carbon-14, it's still carbon. Why? Because it has 6 protons. That's its identity. The only difference is the neutron count, which just changes its weight. They're just different versions of the same element. Simple as that. Now, let's talk about why this actually matters outside of your chemistry textbook. Examiners love asking about real-world uses, so we're going to focus on 2 life-saving isotopes that are absolute exam favorites.
First up, we have a true medical hero, Cobalt-60. This isotope gives off really powerful gamma rays. In radiotherapy, doctors can aim these rays precisely at tumors to destroy cancer cells, all while doing as little damage as possible to the healthy tissue around it. It's a huge part of modern cancer treatment. Next up is iodine-131. Now, what's cool is that our thyroid gland naturally soaks up iodine. So, doctors can give a patient a tiny controlled dose of radioactive iodine-131 to see how the thyroid is working. Or they can use a bigger dose to specifically target and destroy cancerous cells in the thyroid. Pretty clever, right? And hey, don't forget these other superstars. Examiners ask about these all the time. Carbon-14 is for figuring out how old ancient fossils are. Sodium-24 is used to find sneaky leaks in underground pipes. And of course, uranium-235 is the fuel that powers our nuclear reactors.
All right, so you've got the concepts. Now let's turn that knowledge into a strategy for scoring full marks. Because knowing the stuff is only half the battle, right? Applying it correctly when the pressure's on is what really counts.
Okay, listen up, because this is a trap that so many students fall into. They forget the golden rule. Remember, since isotopes have the same number of protons and electrons, their chemical properties are basically the same. It's their physical properties, like their mass or density, that are different. Do not get those mixed up. All right, it's time. Let's go back and face that challenge question from the beginning. Now that you understand the concepts, let's just walk through the calculation together. You'll see it's all about applying one simple formula.
Look how straightforward this is when you just break it down into steps. Step 1, write down the formula for relative atomic mass. Step 2, plug in the values you're given. And don't forget to turn those percentages into decimals. Step 3, simplify the equation. And finally, step 4, solve for y. And there's your answer, 10.05. It's a simple process you can follow every single time.
Okay, to wrap this all up, I want to leave you with one final really powerful idea. If you're in the exam and the pressure gets to you and your mind just goes blank, I want you to come back to this one crucial point.
If you remember absolutely nothing else, remember this. The number of protons is like an element's ID card. It cannot be changed.
An atom with 6 protons is always carbon. An atom with 92 protons is always uranium. The number of neutrons can change, that's what creates isotopes, but that core identity, it always stays the same.
So the big takeaway here isn't just about passing an exam. It's about understanding a fundamental concept in chemistry that literally saves lives, helps us uncover the past, and even powers our future. The real question now is, what amazing new discoveries will the next generation of isotopes bring? That's something to think about. Good luck with your revision.